Be strong, be courageous, do not be frightened, do not be dismayed, for the Lord your God is with you wherever you go. Joshua 1:9. Good day, Grade 10 Science learner. Welcome to our video lesson on electromagnetic waves. For our topic for this video, we will discuss the practical applications of electromagnetic waves. I am your teacher, Sir Guetta. Before we proceed to our lesson proper, let us first review the electromagnetic spectrum. Electromagnetic spectrum contains all the electromagnetic waves that are arranged according to wavelength and frequencies. The first wave is the radio wave, while the last one is gamma rays. They are arranged according to increasing frequency and decreasing wavelength. Radio waves are used to broadcast radio and television. Microwaves used in cooking, radar, telephone, and other signals. Infrared transmits heat from sun, fires, and radiators. Visible light, the only part of the electromagnetic spectrum which is visible to our naked eye. It makes things able to be seen. Ultraviolet absorbed by the skin used in fluorescent tubes. X-rays used to view inside of bodies and objects. And gamma rays used in medicine for killing cancer cells. Let us have our pre-assessment. Kindly please get a piece of paper for your answer. Match the electronic waves in column A with its example in column B. I will give you 1 minute. Or you can pause the video while you are answering. We are going to determine the answers later in this video. The first type of electromagnetic radiation is communication through radio. Radio is needed for transmission of sound and pictures. The sounds and images are converted into electrical signal by a microphone or video camera. These signals are fed to a modulator and at the same time an oscillator circuit generates the fixed frequency carrier waves which are also fed to the modulator. Modulation is the process by which the carrier wave is changed or varied in relation to the original sound's loudness or loudness and intensity are related to the amplitude of the wave. Amplitude modulation, while pitch is related to the frequency or frequency modulation. The modulated carrier wave is also amplified, then applied to the antenna that converts the electrical signal to electromagnetic waves. These are called radio waves. These are transmitted not only by a line of sight, but also by a deflection from the ionosphere. Radio stations broadcast at different frequencies. The antenna of radio wave receivers, like that of the radio set, picks up all the frequencies. But the radio tuner circuit selects the frequency received. The tuning control on a radio receiver adjusts the local oscillator frequency. If the incoming signals are above the threshold of sensitivity of the receiver, and if the receiver is tuned to the frequency of the signal, it will amplify the signal then passes the demodulator, which separates the signal wave itself from the carrier wave. The demodulator signals are then fed into the loudspeaker or display device, where they are converted into sound and visual images respectively. TV broadcasting uses two carrier waves. The picture signals are carried by AM carriers and the sound signals by AM carriers. Both carrier waves are transmitted by the same antenna. In both radio and television receivers, once the basic signals have been separated from the carrier wave, they are fed to the loudspeaker or a display device, where they are converted into sound and visual images respectively. In an AM transmission, the carrier wave is constant in frequency and varies in amplitude or strength. In frequency modulation or FM, the carrier is constant in amplitude and varies in frequency. Microwaves. Microwaves can be used in satellite communications because it can penetrate the atmosphere of the Earth. Communication satellites travel around the Earth at an altitude of 35,000 km above the equator. They move at the speed of 11,300 km per hour and revolve around the Earth every 24 hours, the same rate as the rotation of the Earth. Antennae are mounted to point in fixed directions towards this satellite. Microwaves are commonly used in radar systems, where it uses microwave radiation to detect the range, distance, and other characteristics of sensing devices and mobile broadband applications. Microwave oven is commonly used for cooking purposes without using water. The high energy of the microwave rotates the polar molecules of water, fat, and sugars of the foodstuff. This rotation causes friction that results in heat generation. This process is called dielectric heating. Infrared radiation is generally produced by thermal motion, vibration, and rotation of atoms of molecules. Electronic transmission in atoms and molecules can also produce infrared radiation. Infrared photographs taken from satellites with special film provide useful details of vegetation on the Earth's surface. Infrared scanners are used to show the temperature variation of the body. This can be used for medical diagnosis. Infrared remote controls are used in TV, video cassette recorders, and other electronic appliances. Infrared telescopes are used for seeing in the dark. Autofocus camera has a transmitter that sends out infrared pulses. These pulses are reflected by the object to be photographed back to the camera. The distance of the object is calculated by the time lag between the sending and receiving of pulses. The lens is then driven by a built-in motor to adjust to get the correct focus of the object. Visible light has significant importance in humans. We can see things through light. Visible light has brought many worthwhile purposes in life, not only in our sensing activities. Concentrated visible light used to make laser. It is an acronym for light amplification by stimulated emission of radiation, a device that amplifies or increases the intensity of light and produces highly directional light. It is used in surgical activities. It can also be used in optical fiber communication to send information over large distances with minimal loss. optical fiber works on the principle of total internal reflection. These are thin strands of optically pure glass about a diameter of human hair. They are arranged with bundles, cable, to transmit light over long distances. They are used in telephone systems, medical imaging such as endoscopes, and optical fibers are also used in inspecting mechanical welds in pipes, engines, and inspecting sewer lines. Ultraviolet radiation or UV radiation can be natural or artificial. Natural UV radiation came from the sun, while artificial UV radiation can be obtained from UV lamps. One of the most common types of counterfeit detection is provided by ultraviolet light. The principle is simple. If the bill being checked has fluorescence, then it is genuine. The idea behind this is that the paper used in the printing of real currency has a high starch content, making it appear dull under UV light. UV radiation is also used in sterilizing water from drinking fountains. Ultraviolet radiation from the sun can also be a source of vitamin D and can make our skin tan. But since UV radiation has high energy, too much exposure to it can harm our skin and our eyes. X-rays are produced using an X-ray tube. They emit when fast-moving electrons hit a metal target. X-rays were discovered by Wilhelm Conrad Roentgen in 1895. X-rays use diagnostic tool in dentistry and medicine. Doctors and dentists can examine the condition of a person's bones, the root of the teeth, or the state of other inner parts of the body. These are X-rays with longer wavelengths. While X-rays with shorter wavelength used by custom officers at airport to inspect the content of the luggage using X-rays. Let us check our understanding of the lesson for today. Let us go back to your pretest. Let us recheck whether you are correct or wrong. Let us match the electromagnetic waves in column A with its example in column B. Number 1. Radio waves are for television waves. Microwaves is for satellites. Infrared radiation is for autofocus camera. Visible light is for fiber optics. Ultraviolet is for the sun. X-ray is for the broken bones. Congratulations and thank you for watching our video lesson for today. This will serve as guide in answering your module. But before we end, let us first think the reference of our picture that are used in this video. This video is not possible without these sources. Thank you so much. And of course, to my dear learners, thank you for watching this video again. Good luck with your module and happy learning. See you again in our next video lesson. Thanks and God bless.